Hey everyone, welcome back. In this Math 20-1 lesson, we are learning T3, sine law and cosine law. We will solve oblique triangles, which means triangles that are not necessarily right triangles. We will explain each main point then. Immediately work examples so the method feels practical. If this helps, please like the video and subscribe to the channel. First, the sine law. In any triangle, each side divided by the sine of its opposite angle gives the same ratio. So A over sine A equals B over sine B equals C over sine C. Use sine law when you know an angle and its opposite side pair, plus one more side or angle. Example 1. Suppose angle A is 40 degrees, side is 10, and angle B is 65 degrees. Find side B. We use A over sine A equals B over sine B. Substitute 10 over sine 40 equals B over sine 65. Multiply by sine 65. So B equals 10 sine 65 over sine 40, which is about 14.1. Example 2. Suppose side is 12, angle A is 38 degrees, and side C is 9. Find angle C. Use sine C over C equals sine A over A. So sine C over 9 equals sine 38 over 12. Multiply by 9, and sine C is about 0.462. Therefore, angle C is about 27.5 degrees. Now the ambiguous case, SSA. This happens when you know two sides and an angle that is not between them. Because sine has the same positive value in quadrants 1 and 2, one setup might give one triangle, two triangles, or no triangle. Always test the second angle. Example 3. Let angle A equal 30 degrees, side A equal 8, and side B equal 12. First find sine B equals B sine A over A. That is 12 times sine 30 over 8, which is 0.75. So B could be about 48.6 degrees, or 131.4 degrees. Both leave a positive third angle, so there are two possible triangles. Next, the cosine law. It says c squared equals a squared plus b squared minus 2ab cosine c. Use cosine law when you know two sides and the included angle, or when you know all three sides and need an angle. It is the non-right triangle version of the Pythagorean theorem. Example 4. Two sides are 7 and 11, and the included angle is 50 degrees. Find the opposite side C. Substitute into c squared equals 7 squared plus 11 squared. Minus 2 times 7 times 11 times cosine 50. That gives c squared about 71.0. So c is about 8.4. Example 5. A triangle has sides 8, 10, and 13. Find the angle opposite side 13. Use 13 squared equals 8 squared plus 10 squared minus 2 times 8 times 10 times cosine C. Solve for cosine C, and cosine C is negative 0.03125. Therefore, C is about 91.8 degrees. How do we choose the correct law? If you have an opposite side angle pair, sine law is usually efficient. If you have side angle side, use cosine law. If you have side side side, use cosine law to find an angle. After one missing part is found, you may switch laws to finish the triangle. Example 6. If you know angle A, side A, and angle B, choose sine law because angle A and side A are an opposite pair. Example 7. If you know sides 9 and 14 with the included angle 70 degrees, choose cosine law. Example 8. If you know all three sides, choose cosine law to find the largest angle first. Example 9. Solve a triangle where angle A is 50 degrees, angle B is 60 degrees, and side A is 12. First angle C equals 180 minus 50 minus 60. So C is 70 degrees. Then use sine law. Side B equals 12 sine 60 over sine 50, about 13.6. Side C equals 12 sine 70 over sine 50, about 14.7. Example 10. A surveyor sees 2 points from one location. The distances are 80 meters and 120 meters, and the included angle is 35 degrees. Find the distance between the 2 points. This is side angle side, so use cosine law. D squared equals 80 squared plus 120 squared. Minus 2 times 80 times 120 times cosine 35. The distance is about 71.6 meters. Great work! For T3, remember, sine law needs an opposite pair. The SSA case may be ambiguous. Cosine law handles side angle side and side side side, and real problems often begin by drawing a clean triangle and labeling what is opposite what. Like the video and subscribe for more Math 20-1 lessons.